Reversing a list using a stack data structure is a straightforward process which leverages the last in first out property or first in last out property of stacks. So, here this reversing a list using stack data structure is going to be very simple, and these three are the steps which we are supposed to follow to reverse a list. The very first step is initialize an empty stack, that is our very first step. Very first step is initialize an empty stack. And second step is push all elements of the list onto the stack. Let us consider this list. Imagine this is the list, and the list contains totally 6 elements are there: A, B, C, D, E and F, and this is going to be our initial list. According to the steps, very first step is initialize an empty stack. Yes, empty stack has been initialized, and push all the elements of the list onto the stack. Pushing all the elements one by one from the list onto the stack. First A will be pushing into the stack, then B, after pushing B, then C, D, E and F. All the elements has been pushed onto the stack, and the third step is pop elements from the stack and insert them back into the list. First, let us pop the element one by one from the stack. When you pop it as per the stack property, the element which came last would come out first, and the element which came first would come out last, right. So, only through one end insertion as well as deletion can be done. So, when you pop out, as usual, like first only the topmost element can be popped out. So, F would be popped out first, and then E would be popped out, then D, C, B and A. This is how this is the order in which the elements can be popped out from the stack. So, after inserting all the elements, pushed all the elements into the stack, if you pop out, you will be able to pop out only in the reversed order. So, if you check, the reverse order of the actual list is ready. So, once popping out is done, all the elements from the stack, once popping all the elements from the stack, next we are supposed to insert all these elements back into the list. If you insert without changing its order, if you insert all this back into the list, now the reversed list is ready. By pushing all the elements onto the stack and then popping them, the order of elements is reversed, because the last element is pushed onto the stack will be the first one to be popped out, right. So, always if you want to reverse something, use the data structure, push everything inside and pop out one by one, the reversed list would be ready. The reversed string or reversed list or whatever would be ready. This is how we are supposed to perform reversing a list using a stack data structure. And the second application of stack is balancing symbols to check whether the symbols are balanced. So, this application is mainly used in programming language to check the syntax, as well as in mathematical expressions this would be used. So, mainly here the stack data structure is used to check the validity of the parenthesis in any algebraic expression. And you have to check, always we are supposed to check whether every open bracket, every opening symbol has a corresponding closing symbol, we have to check. Let us see some example here, and before we solve the example, let us discuss what all the steps are there which we are supposed to follow to check whether the given expression is balanced or unbalanced. The very first step is input the given expression. Whatever the expression has been given to you, to check whether it is balanced or unbalanced, you are supposed to input the expression first and put it in the character stack. Once inputting the expression is done, the second step is scan the characters one by one from the expression. For example, A plus B star C has been given. Input the complete expression into the character stack and scan the characters one by one, scan the characters from the entire expressions one by one. And the third step is if the scanned character is a open bracket, because here in the balancing symbol we are going to use the symbol stack, which means only when we encounter the symbol we are supposed to perform the push or pop, whatever may be, like the stack operations can be performed only based on the symbols. So, here for balancing symbols we are supposed to use the symbol stack. Here we will be using symbol stack, which means only when we encounter the symbols the operations would be performed in the stack. So, we will use symbol stack if while scanning the characters, if the scanned character is a open bracket such as this open parenthesis, or if it is a square bracket, or if it is a curly bracket, you have to check. And if it is a open bracket, if it is open, you are supposed to push it into the stack. So, when you encounter the open brackets can be anything, either the parenthesis type or square bracket type or curly brace type, whatever it may be, you have to push it into the stack. And if the scanned character is a close bracket, if it is a close bracket, we are supposed to pop out the topmost element from the stack, and we have to check, we have to compare the current element which we have scanned and the element which we have popped out from the stack is equivalent or not. If it is equivalent symbol, then we can proceed, otherwise we can quit, we can stop, and we can print that the given expression is unbalanced. After scanning all the symbols from the expression, if any parenthesis is left in the stack, which means after scanning all the expressions, all the symbols from the expressions, finally if the stack is not empty, means again the given expression is not balanced. So, we are supposed to follow these 5 steps to check whether the given input expression is balanced or not. The very first step is input the expression into the character and input the expression and put it in a character stack is very first step. So, here this is a given example. Let us take one simple parenthesis example and check. Wait. Okay, this is our very first example. Input the expression as the very first step, create a stack, initialize a stack. Now, after inputting the expression, the second step is scan the characters from the expression one by one. We are supposed to scan the character. While scanning, if the scanned character is a open bracket, we are supposed to push into the stack. If it is a closed bracket, we are supposed to perform the pop operation. Now, if you check while scanning, the first symbol, the first character is a symbol only, which is a open symbol. If it is a open bracket, it is a open square bracket, which is a open bracket only. If it is a open bracket, you are supposed to push it into the stack. Since it is a open bracket, I am pushing it into the stack. After scanning the first one, you can scan the second one. If you scan the second character, again it is a symbol only, which is open parenthesis. Since it is open parenthesis, we have to perform push operation. You have to push it inside the stack. Then again the third character, which is a operand. If it is a operand, you no need to perform anything. Next, if you check it is a operator, again if it is a operator also you can ignore, and then again operand, you no need to perform push or pop, whatever. Only when you encounter the symbols, you are supposed to think about performing push or pop operation. Other than symbol, if you encounter the operand or operator, you no need to perform any operation, just skip it, you just move on to the next position and proceed scanning the characters one by one. Now, the next symbol is close bracket. When you encounter the close bracket, check step number 4. If the scanned character is a close bracket such as close parenthesis or close square bracket or close curly bracket, then pop the topmost symbol from the stack. After popping out the topmost symbol from the stack, check if the popped symbol is equivalent to start symbol or not, we have to check. Now, if you check the current symbol, the current character is the symbol which is a close symbol. So, if you encounter a close symbol, we are supposed to perform the pop operation. Popping operation can be performed only on the topmost element of the stack, which means pop out the topmost element from the stack. The topmost element is the open parenthesis. So, once popped out is done, you are supposed to compare these two, the current scanned character as well as the popped out symbol. You are supposed to check. If both the symbols are equivalent, you can proceed. If it is not equivalent, you have to conclude that the expression is unbalanced. If you check both are parenthesis only, this is close parenthesis and this is open parenthesis. So, both are equivalent. If so, you can proceed. So, this has been popped out. Now, if you check stack, there is only one element in the stack. After popping out the topmost element, now in the stack there is only one element, which is open square bracket, and the next character which we are supposed to scan is this operator, star operator, since it is an operator you no need to perform any operation, and then again operand no need to perform anything. If you scan the next symbol, next character, which is a symbol only, which is close bracket, close square bracket. When you encounter the close bracket, you are supposed to perform pop operation from the stack. If you check the stack, there is only one element, which is this is the topmost element. So pop out the topmost element from the stack. If you pop out, like popping out the open bracket, and this is the topmost element. Once popped out is done, popping out is done, you have to check whether both are equivalent. Yes, this is open square bracket, sorry, this is open square bracket and this is a close square bracket. When you check both are equivalent, if both are equivalent, you can proceed. And again you start scanning the symbols from the expression, but the expression is completely over. There is no new symbol is left out to scan here in the expression, and since there is no symbol here, you have to look at the stack now. Now if you check the stack, we popped out this open bracket also, right? Now if you check, the stack is completely empty. Once the scanning is completely done, you have to check out the stack. Your stack also must be completely empty. If the stack is not empty, again you can conclude that the given expression is unbalanced. So after scanning all the symbols from the expression, if any parenthesis is left in the stack or if the stack is not empty, then the expression is unbalanced. But now if you check here, the scanning is done, scanning all the symbols from the expression are done, and the stack is also empty, which means the symbol is balanced, the expression is balanced, the given expression is balanced. This is how, using stack data structure, we have to check whether the given symbol in the given expression is balanced or not. Let's take one more example. This is the example: A plus B star C star E plus D, and this is the given expression. Let's follow the steps one by one. The very first step is initialize a stack. And you can start scanning the characters from the expression one by one. If you check, the very first symbol is curly bracket only. Since it's open, you are supposed to push it inside the stack. And then again scan the second symbol is again open square bracket, so push inside the stack. Since it's an open bracket, we are supposed to push it inside the stack. And next is the operand, no need to do anything. Then next is again the operator, no need to perform anything. And the next symbol is open bracket. If it is open bracket, again we have to perform push operation, push the open parenthesis inside the stack. And then again operand, ignore it, again operator, ignore it, operand, ignore it. And then again if you check, the symbol is the character is symbol only, which is the close bracket, close square bracket. When you encounter a close bracket, you are supposed to perform pop operation from the stack. So pop out the topmost element from the stack. The topmost element is open bracket, pop this out from the stack. After popping out, if you check the stack, inside the stack there are only two elements. Once popping out is done, you are supposed to check the equivalent of both the symbols, the close symbol as well as the open symbol, we are supposed to check. Once the popping out is done, okay, done. If you check, it is not equivalent only. Why? Because the close bracket is the square bracket and this open bracket is a parenthesis which is not equal. So if it is not getting matched, if it is not equivalent, you have to conclude that the expression is unbalanced. If it is equal, you can proceed. If both are same, if both are equivalent, you can proceed. If it is not equivalent, you can stop and you can print that the given expression is unbalanced. So it would stop till here. Why? Because it, since we came to know that it is unbalanced, no use of scanning or the remaining characters or remaining symbols further. So you can stop till here. Why? Because the expression is unbalanced. Anyhow, it's not going to lead you with the proper result. So you can conclude that the expression is unbalanced. Let's take one more example. This is the example. Initialize the stack. Now let's scan the characters one by one from the expression. If you check the first character, it is a bracket only, open bracket, open curly bracket. Since it's open, you are supposed to push inside the stack. Next, if you check again, it's open bracket, open square bracket, push it inside the stack. Next, if you check this is operand, then again operator, you can ignore all. And now when you reach here, again it is a symbol only, which is a bracket only, which is a close bracket. Sorry, I missed this open one. Okay, let's do it again from the beginning. Okay, the very first symbol is open bracket, which is a curly bracket. We can push it inside the stack, and again there is a open bracket, which is a square bracket. You can push inside the stack. Next, F, which is the operand, you can ignore it. Then again operator plus, you can ignore it. And then again there is a open bracket here. When there is a open bracket, we are supposed to push it inside the stack. Yes, pushed inside the stack. And then again there is an operand, ignore, operator, you can ignore. Again there is an operand, you can ignore. Then again if you check, there is a bracket, which is a close bracket. When you encounter a close bracket, you are supposed to, you cannot perform any push operation. Only open brackets can be pushed into the stack. When you encounter the close bracket, we are supposed to perform pop operation from the stack. As usual, only the stack topmost element can be popped. The stack topmost element is the open parenthesis. We popped out. Now inside the stack there would be only two symbols inside the stack, right? So we popped out the topmost element, which is open parenthesis. Once popped out is done, we are supposed to check whether both are equivalent or not. We have to check if both are equivalent. If the popped character is the equivalent starting bracket, yes, both are equivalent. If so, we can proceed. Yes, the next is star, which is the operator, so no need to do anything. And then again if you check the next character, it is a open bracket, which is open parenthesis. Since it's open, you are supposed to perform insertion into the stack. Yes, I performed insertion. I just pushed the open bracket, open parenthesis into the stack. And next is operand, then again operator, then again operand. No need to do anything, just scan it and move, just increment the position and keep scanning the further characters. And next is the close bracket. When we encounter a close bracket, again we encountered the close bracket, we are supposed to perform the pop operation from the stack. The stack top element is open parenthesis only, you just pop out from the stack. After popping out, it would get deleted from the stack, and now inside the stack there are only two symbols. The popped out is done. After popping it, you check the equivalent of the equivalent of the symbols. Yes, both are parenthesis only. For open parenthesis, for every close parenthesis we found the open parenthesis also. So if it is getting matched, if it is equivalent, we can proceed. Next, the next character to be scanned is this operator plus. Since it's an operator, no need to push into the stack. Again there is an operand, no need to perform anything. And the next symbol is close bracket. Since it is a close bracket, we are supposed to perform the pop operation from the stack. If you check the stack topmost element is open square bracket, it just pop out from the stack. After popping out, one element will get reduced from the stack. Now if you check, yes, popped out is done, and check the equivalent of the symbol. Yes, both are same only, it belongs to same family only. It is a close square bracket. For close square bracket, we found the open square bracket also, both are equivalent. So you can proceed now. The next character is the operator, so you can ignore. Again the next character is the operand only, it can be ignored. And next is the close parenthesis. We encountered the close bracket, so we are supposed to perform the pop operation from the stack. In the stack top element is open curly bracket. After popping out, this would get deleted from the stack. After popping out, check for the equivalent of the symbol. Yes, both are equal only. It is for open curly brace, we found for close curly brace, we found the open curly bracket here. So both are equivalent, we can proceed further. Next, there are no more characters there in the expression to scan, and also if you look at the stack is also empty, which means there are no more characters to scan from the expression, and also the stack is empty. So you can print that the given expression is balanced. Finally, after scanning all the characters from the expression, your stack must be empty, then only you can conclude that the given expression is balanced. Otherwise, it is unbalanced. If the stack is not empty, you can conclude that the given expression is unbalanced. This is how we are supposed to check whether the given symbols are balanced using the stack data structure, and the same is applicable for the programming language also. The compiler would use it to check whether the parenthesis given is balanced or not. If it is not balanced, it would give an error. Thank you.